Alrighty, welcome everyone. This is the SIG Node meeting on May 6, 2025. First up, we have Kevin on pod level resource limit ranger. Take it away, Kevin.
Yeah, well, following up on pod level defaults with the limit ranger, after some discussion, we decided that we are not going to proceed, especially with those changes, because having the changes applying the defaults conditionally would make to also apply the container defaults conditionally, and that would make for us to change the current behavior and would be breaking current functionality. And in the case that we don't apply the defaults conditionally, well, we will still be breaking the container level defaults because of changing the way of deriving the current pod level defaults that are being derived from the container aggregated values. So by this time, we are not going to proceed especially with the pod level defaults. We are still going to do the validation for min and max using the pod level resources when container, even when container aggregated values are present, when pod level resources are being used. So yeah, after this meeting, I will start grading up the KEP, changing grading the findings of the reasons that we are not going to proceed at this time with pod level defaults. But yeah, that's pretty much it.
Great. Thank you for the update. Did anyone have anything they wanted to mention there? Cool. Then let's move on. Marcus or Karthik, are either of you here? Oh,
Hello.
Marcus, I see you.
Is the
Hello.
audio working?
Yes, it is.
Okay, cool.
Do you want to present anything?
Yes, I'm going to present if you
Yeah,
can give me the rights. So
there you go.
First of all, greetings from Kubernetes Community Days from Helsinki, Finland. I've just arrived from there like 5 minutes ago, so that was a great first time event in Helsinki, Finland, for Kubernetes community, like a big event. So first topic, what I'm going to be talking about is node resource discovery. Try to share you the slides. Anything showing up there?
Yeah, you're good to go.
Ah, yeah, thanks. So a new enhancement proposal for which I've created the issue in enhancement repository. I haven't submitted a PR yet. A few weeks ago, I sent an email to SIG Node list with a Google Doc kind of outlining a draft for the KEP PR, and now I thought it would be a good time to present to the SIG Node meeting this proposal and get feedback from the meeting for this. So the motivation for this resource discovery enhancement is to kind of replace cAdvisor with something else for the kind of node capacity discovery. So there are problems with the current cAdvisor approach, especially with configurability, and it sometimes gives incomplete or incorrect information about the hardware and the topology of the hardware, and it's still maintained but not very actively maintained. And there have been also asks from the community to have some kind of a pluggable dynamic controller for the node resources and use cases like that. And this is kind of a sibling enhancement proposal for the node resource hot plug KEP, in the sense that when combining these two, we could kind of enable dynamic node resize with some external controller for the hardware resources. Some user stories for the examples for the kind of dynamic node resize controller scenario would be kind of partitioning the node for Kubernetes managed workloads, and then kind of slice out part of the resources to some other non-Kubernetes workloads. Another user story would be kind of hide some hardware details from Kubernetes. For example, in some scenarios, hide the hyperthreads of the cores from Kubernetes. If somebody would like to do that dynamically or even from the startup, or some other kind of tweaks, use case specific tweaks to the node. Then the third user story here is adding new compute resources, and something that would not necessarily be correctly detected or presented by C advisor currently. For example, hot plugging memory via CLX to the node on demand. And fourth user story here is that something that give insights to the kubelet about like more exotic hardware topologies that the kubelet could handle better if we gave the hardware details in more correct form. So one example is with some hybrid CPU configurations on systems on edge workloads, where you have like small cores and big cores, and then the topology is bit exotic in terms of, for example, cache layout and such. And the proposed solution in the draft currently is that we would make the Sierra runtime the source of truth for the node resources. So extend the Sierra API to have a new service or new RPC for communicating the resources from the runtime up to kubelet. And kubelet would kind of get the capacity at the startup, and then the runtime would inform any changes to kubelet during the runtime of kubelet. And as mentioned there earlier, this is kind of closely related, but sort of totally independent of the node resource hot plug keb. So with this tool, we would kind of get into a state where we have all dynamic node resize, and then would be able to control the node resources in a more flexible way from the runtime, and kubelet wouldn't need to care about the kind of control part of that. Runal, you had some questions, comments.
If we move this to the CRI, won't each container runtime have to implement its own way of discovering resources, and how would that implementation be different? I'm wondering whether it makes sense to just make it pluggable, but not through the CRI. I'm not quite getting the pitch for why it should be done by the container runtime.
So I guess the idea with this would be that there would be a common library that would be shared by other runtimes that could do the resource discovery. It's not like super complicated task to detect what the underlying hardware is from the sysfs directly, for example. But anyway, have a reusable component for that could be used by the container runtimes.
So yeah, I guess like I'll let others go, but a quick comment. So I think why can't we do that in the kubelet directly? Like why push it down the stack and add the overhead of the gRPC calls between the runtime and the kubelet?
Then I don't know who's first, Francisco or Sergey.
Francisco is the first.
Francisco, yeah. Francisco, go ahead.
Thank you. Don't, I see you had your mic open. Do you want to comment before I go?
I just want to comment why macOS, because on the node capability from the CI maybe came from the unified, because the container and the pod we kind of start slowly push to the CI. So the node capability, so like we can unify it. But I do agree with Manu. I also concerned about we have like even more dependency on the container runtime. Yeah, for the even like the Kubernetes startup and the readiness initially. Yeah. Francisco, sorry.
Yeah, no problem. Thank you. We had some conversation back at KubeCon Europe, and now I'm just narrating my recollection. And the idea, if I'm not mistaken, was that the runtime has to do the discovery anyway. So at that point, we can very much use that that information, which I tend to agree. If my memory serves, I tend to agree. Now, I share. I see the point Mrinal is raising. I would say that the nice fact about deferring to the runtime, if we accept the extra dependency, which is another good point, is that we have pretty much a very great basis for an API, because we can, for example, extend the CRI spec. So we get a very good head start with having the framework, for the API, for the message, and so forth. So that could be something in favor of that. And my other and last comment, and then I'm done, is that the multiple implementations, it's another good point, but I think that it is kind of solved by addressing the other bigger problem, which I see, which is the API, the schema for this machine discovery information, which has to be somehow fixed. So this way we can have like a conformance test for whatever the runtime reports, and that will make the pain points degrade, let's say, into implementation details, because at that point, hey, it has to look like this, this field has to be there in this version, and so forth, which is something which we would arguably also have needed for CAdvisor, in my opinion. So this is having a schema will solve the implementation thingy, I believe, and we will very much want the schema. Now and done. Thank you.
Yeah.
Sergey.
Thank you, Marcus, for presentation. And if you have a link to the slide deck, if you can put it on the agenda doc, it will be very useful.
I will.
If you're ready to share.
Yeah.
Thank you. But comment that I have is we have another API, like CRI API for pod level metrics cap. And that one was quite easy for me to digest, because we don't use those metrics in Kubernetes ourselves. We just pass it along to end users, and end users will look at those metrics and make their own decisions. So we just like upload the metrics collection to CRI, and we don't put any semantic on those metrics. Like whatever CRI wants to report, we will just proxy to the end user. The problem starts when we start making decisions based on this metrics. Like if you, one of the scenario in your slide deck was that we only allocate part of a VM to Kubernetes to manage, but then like how eviction will work? Like will eviction thresholds still apply? Do we keep the semantic or we need to change the semantic? How do we like like garbage collection? Like do we need to trigger garbage collection when we close to the limit, or like we can wait a little bit? So all the semantics needs to be reviewed, and we need to put really careful, really strong semantical conventions on how those metrics will be used and how they need to be reported, and what will happen if the metrics are not collected or not reported properly. So like if CRI is not available, like we suddenly cannot evict anything because we don't know whether we which one we want to evict. All this consideration is to put review it, and like whenever we move any metrics that we depend on to some other source of truth, something that we don't control and something pluggable, we need to really think about all the semantics and how the semantic will affect how kubelet works and how stable the system is.
Yeah. My comment on this is that in my view, kind of all the kind of hard questions on the pod eviction and what happens in what scenarios is they're kind of part of the node resource hot plug or hot unplug kept, in the sense that whatever the source is it CRI advisor or CRI or some other plugin mechanism? I guess all you always have the same concerns. So kind of the source of the information is not. I mean, it doesn't. The source of the information doesn't kind of matter in this case. So kind of this cap is just to try to kind of replace CRI advisor with some other source, but then what kubelet or how it handles the different kind of or different scenarios, that's something kind of out of the scope of this particular cap.
Yeah, at the moment it's pluggable. We need to assume that there will be crazy implementations that we don't control, and we need to make sure that we like have some sense of like have some good reactions on those values returned by this implementation.
Yeah. Tim, you're next.
Yeah, I was also going to bring up the pod resource metrics moving into the CRI, but I actually think this is an argument for this approach, that the CRI is already handling pod and container level resource accounting, and so making it kind of be consistent with the node level capacity as well makes sense to me. The kubelet is still managing pod level C groups.
Yeah.
And I don't know if we see that moving to the runtime at any point in the future, but that's that would sort of complete the picture of the runtime managing the resource setup.
I would like to see that, but yeah. Any more questions? I have still a few slides. So this is we have a proof of concept implementation for this. If we have time, I can show a short demo of that. I don't know if we have time, but the idea is that kind of simple way to depict this is that like first the runtime detects the available resources from the system or controller, whatever, how the system is partitioned and whatever. And then when kubelet starts, it opens a streaming interface to the runtime, and then runtimes at the startup kind of sends what is available, and then kubelet finishes the startup phase, initializes its managers if they're CPU managers and all other components if they are enabled, and so on. And then when kubelet is running, then resource available resources change, the runtime detects that or gets the information from wherever it gets it. Then the runtime sends the updated kind of capacity to kubelet. And then if the node resource hot plug is enabled, then the kubelet will kind of take the stuff in use, update the node capacity and reinitialize the controllers and stuff and so on. So this is the thinking how it would look like. I see 2 raised hands. I don't see who they are.
I think Sartres came before me.
Yeah, I have a question. I mean, you mentioned there reinitialize the manager, so I'm just thinking this would not be possible without draining. For example, the CPU manager, you cannot do it, the update, while the pods are up because you have pinned the CPU, correct?
Yeah. This kind of reinitializing the managers and all that that is part of the node resource hot plug kept. So if the node resource hot plug isn't enabled, then the kubelet kind of doesn't do anything, just omits the stuff. Like similar what currently happens if the admin just goes and offlines like half of the CPUs, the kubelet just doesn't do anything. Kind of similar case. Yeah. So, but if the node resource hot plug is enabled, then the kubelet will handle it. So short. Okay, here I have actually the link to the doc. I'll add it to the SIG Node meeting notes as well. But anyway, I've created the issue, sent the draft doc for discussion, and I'm planning to like submit a PR in like near future. So we have a POC implementation with kubelet cryo and like NRI to like really hacked version of NRI to have some controller to to just act kind of as a controller, dynamic controller of resources. Ajay.
Thanks, Marcus.
Yeah.
This is great. I just have some quick questions on your diagram. Could you go back to the, this one? What does finished startup mean here? How do you think kubelet should interpret that signal? And you also, as a follow-up to that, you also mentioned like CRI updating this change, like a status change to the kubelet. What would it look like in kubelet? I mean, the granularity of the signals, and what do you think they should expect reflect in kubelet? Could you maybe add a bit more on that?
So the finished startup is just the kubelet kind of kubelet startup sequence. So kind of replace the C advisor machine info with the info coming from CRI kind of. So the kubelet kind of code flow doesn't change much, and same with when the resources change. So it's the kubelet code doesn't change much. So kind of replace C advisor machine info with info that comes from the CRI. Did that answer your question, or did that?
Yeah, basically this is not like the ready signal. The kubelet would have a dynamic update on the individual resource update.
No, it's not part of this proposal. So the node resource hot plug has some kind of, currently the proposal has some readiness. For example, if the capacity is decreased, then with the hot plug we wouldn't support hot unplug, so the node would go to not ready state. but that's, well, no reason to hot plug also proposal still under discussion. So Dawn, you're next.
So from high level, push those resource discovery to the CI. I think we've been discussed. From high level, I generally agree. I'm okay with that one. But the use cases you present here get me concern, because my concern it is more like we partition of the node and the two orchestration controller to manage because this is software partition of the node, and make the two system to manage those things. So the complexity actually is not just on the node side, it's more this flexibility, extensibility could make this whole things all abusively to use, right? So the end up could be like the Kubernetes managing half of the node, because CRI only reports half of the resource, and could be have all this kind of flexibility because it's plugin, and then report another half of the resource. And how we are going to really guarantee, because you are just, of course, the hard plugin resource, that's what I want to support for a long time, because, I don't think about we are comfortable to support the soft partition of the node for two, so make the single node and join off the cluster. And when it is, for example, managed by Snarm, another partial managed by Kubernetes, I don't think that's the good use cases. I know there's the proposal. I've been working with the Snarm folks, and I'm really want to Snarm on top of the Kubernetes, and we give them extensibility, final ground of the resource management. That's what I proposed. I think last year I proposed those kind of things, but I don't want to soft the partition of the node. We failed for Mesos in the past, and I don't want to repeat the same things. And so what you propose actually make that is the one of the use cases actually run a bio on me and on this one. So I want to say that, because this is the problem. People only look at node, think about this might be no big deal, but then how are we going to preemption? How are we going to maintain off the priority, all those kind of things between two orchestrations? Today, we already have the problem to solve that risk condition between auto scaling and the scheduler, right? So that's why I propose to using pod or whatever some like the reservation to minimize those risk conditions. So that's why workload and also Snarm workload on top of Kubernetes, and we give them more flexibility, all those kind of things. But on top of that, then so other things that at the same level, but the same group of the node, they just partition. So that's kind of like the complexity at the orchestration level, which is a little bit difficult to maintain. Yeah, that's my comment.
Yeah. I guess some use cases see kubelet and Kubernetes just as a other system daemon, and there are others as well. So I don't know if we can kind of force that people wouldn't do that. Like
So,
whatever, and people already try to do like C-advisor, like mocking sysfs to kind of fake the resources that are available. So kind of people are definitely going to find workarounds. So I don't know how that could be sort of prevented in a sense.
people fork Kubernetes for their own product, it's okay, but that's not conform Kubernetes. This approach ring a bell for me. It is in the past we just say Kubernetes is the source of the truth of the resource on a given local, right? So local node, the source of the truth of the resource. So we extended, but still Kubernetes is the source of the truth. And this proposal basically open a can of the worm. Is like okay, Kubernetes is not the source of the truth. CRI could be, and then CRI and could be shared by multiple of the node agent and deny to the node agent, which is a Kubernetes, or maybe could, for example, Snarmly could be, and then orchestration to support orchestration, and then end up the problem is not what we have today, right? So I would rather node carry some local complexity, but now we just effectively to shift all the problem to the control plane, and I worry about this is make of the Kubernetes useless, okay? Because methods doing this kind of things in the past and make methods failed badly. There's too many extensibility and too coexisting for a lot of the orchestrations. And so that's my concern here. Yeah.
Yeah, I could also look at from the point that maybe, I mean, for example, in the case of containerd, there might be Kubernetes using that, and then you could run like Docker on the side as well in some use cases. So, but yeah, I have no kind of definitive answer then what should be available or possible or not, but and regarding the resources, my kind of view is that Kubernetes still doesn't have kind of ultimate control over the resources, so it kind of needs somehow to accept what the admin does, in a sense, like whatever offlining CPUs or adding memory. So the Kubernetes cannot control that. It should just adapt to the changes. That's kind of the thinking behind this proposal. But yeah, definitely, I guess we need to discuss that aspect.
Yeah, continue discuss. But I need the hard plugin resource I do want to support. I think we have to evolve node capability discovery. And but again, even that one, we need to talk about the scheduler, right? So scheduler today, think about the node is the fixed size still. You need to change the scheduler. Yeah.
Yeah, there are just some thoughts on the roadmap. So alpha would be get resources from whatever, well, in this case, CRI, and then fall back to C advisor is supported. And then in beta, the same, but add warnings in logs. And I don't know, Frances commented that maybe we should add node condition that like warn users that, okay, I guess this would be some like more generic enhancement in the sense for if the runtime is having some deprecated or too old version of runtime, so you would have a node condition that kind of showing the users in a more visible way that, hey, please upgrade the runtime, and then in GA remove fallback and the C advisor related code. And then just some alternatives discussed in the draft as well. So new kind of socket gRPC plugin interface to Kubernetes, that would be one. Then Tim kind of pondered around having config files or kind of editing the Kubernetes API object directly or some combination of these, or then extending C advisor, making it pluggable or whatever. Many of these, I think, have the problem of the kind of bootstrapping. So where would Kubernetes get the initial set of resources? And then a new plugin interface. I don't know how different that would be from the kind of CRI approach. And then some concerns that people kind of raised in the draft document comments. So should this really be in the scope of runtimes? The bootstrapping easily becomes an issue, how to and where to get the resources when the Kubernetes starts. And well, then Francesco also suggested that maybe in the CRI we should have a new service for this kind of discovery service, and then we could actually, if the runtime wouldn't implement it, then you could just point Kubernetes to another socket, like a discovery service endpoint that would then implement this part of the CRI. And yeah, Yuju raised the concern that what if the controller does something that contradicts like running workloads, but I guess that's somehow ultimately anyway outside of the Kubernetes control. If some resources really disappear, there's not much that Kubernetes can kind of do about that. But yeah, any more questions on this one? I think I spent quite a bit of time some of this subject already.
Thanks. I guess we can continue discussing. And,
yeah, I'll add the link to the doc to the meeting notes. Then probably next week or the week after, we could discuss we will get some comments and we could discuss the kind of API details. I have some backup slides, but let's not go there this week, but in the future weeks, discuss the API, how it could look like.
Great. Thank you, Marcus, for bringing this up. Yeah, let's follow up offline and maybe back online in the coming weeks.
Yeah,
you didn't have anything else you wanted to bring up with Node resource hot plug, right? That was just a corollary issue that you wanted to call out.
Yeah. Well, I had the demo, but I can do. I'll do it like next week or the week after.
Okay, sounds good.
Save some time.
Well,
So,
you're still up with Zvonko if you want to talk passed on resource CRI.
Yeah, I just wanted to bring this up again. The KEP that has been open for quite a while. This some presentation that I did like last year. I just noted that Sergey had added like the long document for about this subject. So I didn't have time to read that. I just noticed that I was in the
maybe we can in the interest of time switch to this document discussion and then
yeah, that sounds fine.
Yeah.
Great. Let's talk about that.
Or Sergey, do you want to?
It's fine.
Sure.
If you can, it's fine. Yeah. So to set the context on that, we do recognize that this KEP was around for 2 years already, and we definitely need to do something about it for some scenarios. Like we know that there are scenarios that are important. However, and we know that change of CRI will, there will be needed for change in CRI, and this change will come with a cost. I try to put some opinion like how changes proposed on this KEP are not may not be what we want to do long term, and like how we can improve KEP overall by addressing those concerns. And I formulated it in the form of opinion because it's not like we will never do this or we will never do that. It's more of a the like specific change that mentioned is maybe hurting extensibility or hurting our velocity, and we need to understand how we can either do a little bit different change, or we still need to do this change, but we'll make sure we document it well, like how the decision was made and why we don't we still need to do the change even though like it has some potential problems for future. And the same, like I started with the same as premise as before, like whenever we do change like pluggable something or like extend API, we have some scenarios in mind that we want to support, but we also maybe like, for example, previous one, like what Francesca wrote in the chat, we want to replace how we collect metrics because C advisor is not very extensible. Like we want to do like extensible mechanism to collect those metrics, so we'll be so it will be easier for everybody. But at the same time, we do recognize that like once we do that, suddenly and immediately we enabled scenario when node is partitioned, but we didn't enable the scenario per se. We only enabled part of it. Like we enabled metrics collection for it, but we didn't didn't tell our customers how to know about this case, how monitoring tools will react on that, how they also like how eviction will work, like all these side effects will maybe affected. So same thing for this cap. I started with like as a premise that cap was only updating couple CRI calls, but the problem with that is we don't know whether those CRI calls will even work for Kata containers. So we don't know whether it will work for NRI containers that are also NRI plugins that are also listed as a scenario. And since the scenario is very vague, we cannot tell like whether we succeeded in our cap or not succeeded in our cap. We just we passed extra data. Like, is it enough? Is it not enough? Nobody knows. And also it hurts us because since it's just CRI, we don't know whether end-to-end scenario will require some API changes, and maybe we overlooked those API changes that need to be made on pod spec or any other place. So those two first topics are problems with scoping of the cap and how we will ensure that cap is doing what we want it to do. And then if you scroll a little bit down, so what yeah, so this one is about duplication information. So we have this problem with Kata containers. We want one information like original request and limits, and today we don't pass original request and limits. We only pass C group values that needs to be set on C groups, and it also hurt us if we will start sending both now. Like we start sending both, it kind of make an explicit contract, like how one value depends on another value, and people may interchangeably use them in the downstream implementation. And then if we change one of the value and didn't change another value, like we change the algorithm how we calculate C group values, we may break somebody. And it creates some technical debt for us. Like every time we need to change the algorithm of how we calculate the C group values, we need to think of like who we ever can break and what was the transition will look like. Do we need 3 versions to transition from one algorithm to another algorithm? Because downstream maybe some usage of the old values. Yeah, if you scroll a bit down. Yeah, the next one talking about yeah, I'm trying to remember the sequencing. So yeah, so if we pass a lot of information in a pod sandbox creation, we don't know whether runtime will decide to like allocate everything early and like block all the resources, or like and then like if Kubernetes will decide to do, if runtime will decide to do that, then we end up in situation when Kubernetes by propagating all this information early, it locked itself down, and like we cannot optimize anything on a pod bootstrap any longer. We cannot like since like Kubernetes knows how init containers will be initiated. Like it will initiate init containers first and start regular containers. And today we don't optimize this flow. We just assume that it's already pre-allocated. But in the future, we may pre-allocate it. We, especially with in-place resize and other caps like that, we can like very requested features to bootstrap to give a lot of resource on initialization. So all the cache population will have a lot of resources to use, and then shrink it down for runtime. So in runtime, it doesn't need all this extensive resources. So we locked ourselves into implementation that is limiting us in future. And another thing is the cap is proposing to propagate information like whether a container is a sidecar, or whether it contains init container or like regular container. And there's a big and drastic change with what it was before. Like before, we had a situation when Kubernetes knows what to do, like and it asks runtime to implement those things. Like Kubernetes wants to start the container, it will start the container. Kubernetes knows when container needs to be terminated, and it will terminate this container. Now, if you pass information saying like this is a sidecar, now told runtime about semantic of a container, and instead of kubelet now controlling the lifecycle of this container, now we propagated semantic of it. And like if you decide to say like sidecars are now terminating differently, like now we have like different order of terminating, or we have extra property on init container as opposite of restart always or restart never. We have like a longer initialization, and it will run through like part of workload, but then it can finish at some point. So like different life cycle. So now to introduce this type of container, we will need to propagate this information about this type of containers to runtime, and then wait a release of runtime to know about this container type. And then after release happened, only then we can actually implement the feature in kubelet. So it kind of slowed down and like moved control over life cycle of the feature to runtime, instead of kubelet being in control of how like different container types are being worked on. And lastly, I think one big thing we need to handle is reacting, like how we deal with all the dynamisms that we introduce on node lifecycle, like how like node can be like hot plugged or anything like that, or pod lifecycle, like pod can be dynamically resized. And in future, we may even think of adding containers dynamically to the pod, like how all the dynamism that we want to implement in one type of container runtimes be not being like delayed or slowed down by supporting of different type of containers. So maybe like if you shrink API a little bit and make sure its API is smaller, maybe it will be easier for us to do both. So yeah, I think that was the last one. Yeah, Satiris?
Yeah, Sergey, I mean, a lot of information in a very short time. It's a very interesting topic, but I mean, what is the summary that we should take view on this document that you have shared, the CAP, the use cases, the kata? I'm a little bit, sorry, I'm a little bit confused now. But
yeah, good point. Like I started this document, and I thought that I will also write some recommendations, like how to resolve this, like how to address it. But then I realized that I don't know all the scenarios that needs to be supported, and I don't know whether kata will be supported completely. So I started talking to Ronald and like getting some more details, like what can we offer. And I think that we need to work together and understand how to address those concerns and problems, and maybe how to like adapt the CAP to address those concerns. Yeah, Mrunal has a hand.
Yeah,
okay, absolutely.
Yeah. Sorry. So I went and made a pass, and I chatted with Sergey a little. So I think I want to make 2-3 points. So one is in many cases we say that we'll use this information through NRI or we'll do some optimization, but it's not clear what that optimization is exactly and whether it's going to conflict with other changes that we make to the pod lifecycle through the kubelet later on. So having those examples will be useful. So we have a very clear list of what we are trying to support here. It seems like right now you're saying we get this information and then we'll be able to do some things downstream in NRI, and probably that's making the scope too broad. So that was one thing. Be more specific about the use cases. The second thing is I think I saw a couple of places where we said that, oh, we need to duplicate this information in create container call as well, because in place VPA might have changed it. I think that's probably the wrong approach. And I mean, the container runtime should not be trying to infer from changes and resource sizes between run sandbox and create container to know if in place VPA triggered something. Like I would rather that be handled at the kubelet level, and kubelet has full visibility of which calls were already made before a in place VPA was triggered. Maybe Tim can add more there. So maybe if we can scope exactly what we are trying to solve, and we can scope down the changes, then it'll be easier to make progress.
Yeah, just to reiterate, I think Cap had like many comments, and I had the feeling that we don't understand the concerns of each other. Like I think I put a lot of concerns, and they never were written down like details, and it created this problem of how to iterate further, how to move forward on that. So now I put those concerns like very explicitly in like in a document, so it should be much easier to iterate after that. And I'm very open to discussing like how like which concerns can be higher priority, lower priority, but they're all real. There is no like we need to make sure that we are not what we support in upstream is what we're committing to support.
Yeah, and I think like again, I want to reiterate what Sergey said earlier. We want to work together and see if we can find a way forward for this. Okay, so this is not saying, oh, okay, we can't do it, but let's figure out how we can address some of the concerns here and make progress.
Yeah, thank you, Sergey. Really appreciate that you put together this document. As I said, I haven't had the time. I didn't have the time to read that or like read
Yeah,
that
and you
through.
put it today, so
I comment. Yeah, but really appreciate that kind of and constructive kind of way, and a good way in the sense that there are a lot of comments in the PR already, and it's really starts to be hard to follow the discussion there. So yeah, we're running out of time here, and definitely I guess one big concern there is that what you raised in the sense that we'll always be there with like confidential containers, for example, because there you probably don't be able to resize the pod or change the kind of anything after the creation. So that's something I don't know. This CAPE should or proposal should resolve, or would we need some other like enhancement in that area so that somehow the runtime classes could be described that okay, this runtime handler doesn't support any updates, or yeah, I don't know. I guess there are.
Yeah. We will need something like that, right? Like, okay, this class doesn't have these capabilities, and how do we express that cleanly? That's something we'll have to capture. Yeah.
Yep. Let's set up a couple calls to go over the details. We've got some expectations, of course, that pod metadata won't change from the initial pod create run, to the containers.
Yeah.
So when we do receive that meta, we would expect normally. I mean, if it can change, that's fine. We just need to understand the scenarios better.
Yeah, and one option would be like update sandbox call maybe declined by runtime, and we need to make sure that Kubernetes clearly reacting on this case, and it's not an unexpected call, like unexpected failure. It's a quite expected reaction of runtime declining the resize.
Yeah. We're running out of time. This is just one slide from the deck that a few slides that I had, but kind of the intent, what we are trying to achieve is kind of reduce the amount of hacks that is currently used in all over the places to support these kind of different, let's say, kata confidential computing and other use cases. Kind of from the device plugins, for example, at the moment, some device plugins register themselves both as a device plugin and a mutating admission webhook, and then do some crazy stuff like adding annotations. And I guess there are a lot of risks for, like, I don't know, deadlocks or whatnot in this, especially if there are multiple device plugins that like this kind of doing stuff and accessing API controller and kubelet at the same time. And there are a lot of hacks that we'd like to get to, like make or remove from the setups that are currently in place. But yeah, I appreciate like really putting your time on this. And yeah, probably we need to have a separate sessions on the interested parties on this subject to discuss the details as well, and then of course come back to SIG Node as well. But yeah.
Yeah, and if anybody like this is a kata approach, but if anybody interested to discuss peer pods and how confidential may run with peer pod approach and what limitations there are, I'm open to conversation because it's an interesting topic for me.
Great. I think we're at time. So yeah, we'll have to defer your item Itamar to next week. But folks, just take a look at the 2 documents that are shared in the last item. Maybe we can have a more targeted conversation next week about it.
Yeah.
But yeah, thank you everyone for a productive meeting, and I hope to see you next week.
Thank you.
Yeah,
Thank you for taking most of the time. Yeah. Bye.